Hello, and welcome to ArcGIS API for JavaScript, Programming Patterns and Fundamentals. Renee and I are going to teach you the basics of the latest version of the ArcGIS API for JavaScript, including working with webmaps, layers, 2D and 3D views, and we'll also take a look at the available widgets. Renee will cover the fundamentals of watching for property changes, autocasting, and lazy loading data in your app. The link to the slides is available. The link to the location where the slides are is listed here on this main page, so you have access to the slides and demo links that we show you. You get a lot with the 4X API. You get a simplified and consistent API. You can build apps using ES6 or TypeScript, and it's supported in over 30 locales. We have a link here to a sample application showing the app loading with a Japanese locale. And if you look, you can see that the placeholder text for the search widget and the tooltips for the out-of-the-box widgets are all available in Japanese. So when you think about getting started, there's not really any reason to start from scratch. You can use one of the starter applications. If we go to the Esri organization on GitHub, we can see that there's a bunch of different applications. You can browse through these apps and look to see if there's one that provides some, or maybe if you're really lucky, all of the capabilities you need in your application. One app I suggest looking at is Renee's CLI app. You can find it by just searching for CLI, and then it's the first result that comes back. You can use this app as sort of a quick way to get up and running using the JavaScript API and available widgets. There are also a ton of widgets in the API that you can use. They provide access to common functionality like search, legend, layer list, bookmarks, scale bars, and more. So they're a quick way to add bits of functionality to your application. So let's take a closer look at working with the widgets. We have a lot of them in the API. If you look in the developer help, there are, I think, around 40 of them. You can see samples available for a lot of them here. We also filtered this search right here to look at all of the samples that include the word widget, and there are 49 of them. So it's worth looking through those samples, spending some time becoming familiar with the capabilities that are available. So like I mentioned earlier, there are about 40 of those widgets that are available out of the box. And these can help you build great apps because they have all this standardized, pre-encapsulated functionality that you can just plug into your app and get running. Like, less code for you to write, that's always a good thing. And these widgets were designed to be responsive and accessible. So if you're viewing an app that needs to work well on a mobile device or on a desktop, these widgets will respond to those different device sizes and display well. The first widget we're going to look at is expand. This is a clickable button we can see in this little GIF that's running. You click it and it opens up this container that contains some other content. This can be pretty much anything you want, you can put in there. In this example, we've put the legend in one of these containers. You can define an expand icon and collapse icon to use for this expand button. If you're putting an out-of-the-box JS API widget in that container, it's going to, by default, use the widget's default icon for that expand icon. So if you look in the image again, you'll see that we have the legend icon and the base map icon. So users understand what will happen when they click that button. You can also specify the group property to make sure that if you open one container, another container will close. So what I usually do is I specify the group as the corner of the view where I put the content. So in this case, we have two widgets in the bottom left corner. So I can add them to a group that I'll call bottom left. So when I open one, the other one closes. Finally, we have a mode option. Mode lets us determine if the widget will be floating or docked in a panel, or sort of this auto mode where it will do what it thinks is best. ArcGIS Online and Enterprise content can easily be used by the applications by defining the portal URL using Esri/config. If we do this, we can bring in a lot of information into our app from portal. So let's take a look at this really quickly. So here we have our application. And it looks pretty straightforward. straightforward. We just have the standard search box. We have a few tools available, base map gallery and the print button. But if we provide the portal URL here, let's just uncomment this line of code that sets the portal URL, save and rerun our application, we'll see that there are quite a few changes. Our search box now has a bunch of locators available. Our base map and default extent changed. We added this logo here in the bottom right corner, and the base map gallery will potentially display a different set of base maps than the default. So we get all this because we specified that portal URL, and then we can take advantage of some portal properties. So the first thing that we do is the base map. When we create our map, we look at the portal property to see if we should use vector base maps. If it says that we should use vector base maps, we get the default vector base map. Otherwise, we get the default base map. We also use the default extent that's defined in the portal to overwrite the extent that we have specified in our web map. For the scale bar, we can take the default units that are specified in the portal. So if the portal is metric or non-metric, we can make sure our scale bar represents that preference as well. The search widget will pull in all your locator options if you have Esri config portal URL set. So if you have org locators defined, those will also be used in the search widget. The base map gallery also has some logic to check to see if vector base maps are enabled, and if so, they will use those vector base maps too. And finally, we take the print service URL and use that instead of the out-of-the-box print service URL. The last thing we did, you might have noticed that we have like this green color scheme going on. We get that because in the portal you can define shared theming where users can set, organizations can set some preferred color schemes. They can define a logo and they can define background and text colors. So we just pull those values in and apply them in our application. And as I mentioned earlier, all of the links and content is available in the slide link on the first slide, so you can go ahead and take a look at those later when you have time. So the pop-ups, one of the most used widgets is the pop-up. So the new pop-ups in 4X are responsive. They're dockable, so you can dock them in a corner, you can dock them to the bottom of the map. You can also add a lot of different content, fields, charts, custom HTML content, arcade expressions, and much more. We have a lot of samples in the developer help that show how to work with pop-ups. So if we come here, here is one that just lets us see this pop-up. In this example, they have it pre-docked to the upper right corner. So anytime you select a feature, it's going to dock in that corner and display that content. Here, the content was put together by using an arcade expression. But if you look and you search for the samples, you'll see that we have a ton of pop-up samples. So there's 16 that have some examples of working with various pop-up capabilities. You can author all that pop-up content in code, but I think it's easier to author the pop-up content in ArcGIS Online. So you can create a web map or a web scene, you can add your layers in ArcGIS Online or Enterprise, and you can configure the pop-up. I think the new Map Viewer Beta has some really nice tools for configuring your attachments to display as these larger images, so that's something that's cool and worth checking out. That those updates will be carried over into your 4X application. We can also use the layer.fromPortalItem. If you use that method to add a layer to your application, then it will also bring across the pop-up information. So let's look at an example of that. Here's some sample code available in the SDK called layer.fromPortalItem. Well, this layer should be loading and it's not. Okay, we just had to zoom in a bit. So here we can click on one of the pop-ups and we can see that we have the pop-up as we formatted it in the ArcGIS Online Map Viewer. So we can see all that content. And if we look at the source code for this app, we can see that we're not defining a pop-up anywhere. We're just getting it because we're bringing in that portal item. So the pop-up content was defined in the map viewer, saved with the layer, and we get to take advantage of it in our application. Another nice way of displaying pop-up content is with the feature widget. So the feature widget takes that pop-up template content information, either that you've defined in the application or from the web map, web scene, or layer item, and lets you display it someplace else. So some common ways that people display it are maybe you want to hover and display that information in sort of a floating tooltip or in a side panel. So this image here has an example of the pop-up content being displayed in a side panel. It's a sample from the help, so we'll take a look at it live. So in this case, when we hover over features, it displays that pop-up content in the side panel instead of in a pop-up window. There's also one for just a standard hover that you can explore later. So the general architecture of widgets is that the widget framework has two parts, the view and the view model. The view is responsible for how the widget looks and for handling user interaction. The view model is the business logic, so basically its underlying functionality. This makes portions of the widget more reusable. For example, you might want to create a custom view to define a new look and feel for the widget, while still using the underlying logic of the view model. Or maybe you just want to use the view model and take advantage of that business logic in your application without having the widget or the view displayed. So here's an example of the API reference for the search view model. So all of these are docked in the SDK, the view and the view model. So here's an example of a custom view. So this isn't a custom view for the expand widget. We wanted to create a widget that would hold multiple components and expand collapse. In this case, it's a mobile application where you want to provide access to these tools and hide them or collapse them behind a single button. So instead of creating our own widget, we just took the expand, we went to the expand class in the API, and you can notice that we have source code for that widget view. So we can open that up and look at it, and you can see that all of the widget view is here. So what we did for our example application is we just copied this, made a few changes so that we add more than one component into the collapse expand container, and that's it. We didn't have to change the view model. We didn't have to change the underlying functionality. All we changed was a little bit of logic in the rendering. So the link to this changed view model is also available if you click on that link in the help, and you can see the changes that we made there. Another option is to just use the view model. So this, again, if you remember from a few slides ago, is the business logic and communication. So let's take a look at the JavaScript in this application. Basically, we create a new search view model, pass in the view, and then when we click on the view, we use the search view model search method to find information about that clicked map point. So let's click a location on the map, and we can see that we get that search information back. We're not using the search widget. You don't have the search box where you type information in. We're just using the search view model. So there's lots of out-of-the-box theme options available. If we run this application, we can see that by default, we have all the widgets styled with the light theme, but there are a bunch of different options to choose from. So dark green, light red, dark blue, and more. Basically, the only thing you have to do to use another one of those widgets is to change the CSS. Let's just find a little bit of code here that does that. So here, this is an older app, so it's pointing to 4.11, but we can do the same thing pointing to the latest version, which is 4.14, /Esri/themes, and then we just have the theme picker value. This would be the color that you want. So light-green, dark-green, light-purple, etc. You can also set up your app to respect a user's preference for light or dark theming by using the media features available on the link. The media feature expression allows you to test for a user's preference and display that or load that specified style sheet. So nowadays, people often want a light theme or a dark theme. So here we can look at the prefers color scheme, see if they prefer dark. If they do, we can load the dark CSS. If they prefer light or they don't have a preference, we'll load the light CSS. You can also use Sass to define your own custom Sass theme. There's a utility available on GitHub to help you through this process. So if you go here and take a look, it's got lots of information on how you can create your own custom Sass theme, maybe that uses your organization's color scheme or something that a designer mocked up for you. So maps and views are the next thing that we're going to be talking about. So maps basically define the layers and base maps. Well, the view itself is used to display the map content, define things like the extent or viewpoint, and handle all user interaction. So we're going to take a look at a few examples of these two different things, maps and views. So here's an example where we have a map. We define the base map and optionally add any layers to the map. And then here we've got one map view. Map view is the 2D view of the map where we pass in this map value. We also have a new scene view, which is a 3D view. We pass that same map into it. So this is how we create one map and have a 2D view of it and a 3D view of that same map. So you can switch back and forth between multiple views. So you can switch back and forth between multiple views. And we have samples in the API showing how to do this. There's this one here, swap maps, and there's this other one under limitations that is a switch from 2D to 3D. If you're switching from 2D to 3D, you can use the same map, but for all but the simplest maps, it's sometimes easier to use a separate web map and web scene, so you don't need to handle the code to check for things like unsupported symbology. So if we look at this limitations link, it's going to open up this switch from 2D to 3D map. When it loads, we can see here that we're looking at 2D, and then we can switch out to 3D. So now we have more of a globe view. I wanted to link to this article because I think they have a nice section here where they talk about the limitations about switching between 2D and 3D and some of the things that you need to think about, like data types that maybe don't make sense in 2D, or symbols that are 3D only and don't work in 2D or vice versa. Also, additional UI components that you might want to add and remove depending upon whether you're 2D or 3D. So it's worth taking a look at this sample and also reading about the various limitations. We also have a swap map sample that shows how to swap the web map in the current view. So here we're looking at a web map that's missing migrants. We can click on this tab and switch to another one that's called refugee routes. And finally, we switch the view to point to this third web map, which is European Sea arrivals. So both web maps, or both sample apps, have some interesting capability and it's worth reading through. So convenience strings are available and they make it easy to use one of the available named base maps. So we have a whole list of them here. You can use some of the vector-based maps, National Geographic, OpenStreetMap, dark gray base maps. So you can quickly create your map, specify a base map with one of these named strings, or you can create your own base map or define your own base map using the base map class and pointing to your own base map services. So for 3D maps, you can also use one of the strings to define surface properties for the map, or you can define your own using the ground class. So the two available ground strings are world elevation and world topobathymetry. So collections are super useful in the API. These collections store an array of items of the same type and provide utility methods for working with those items. So you can do things like find, reduce for each. You can add and remove items from the collection as well. So here's a little example in the code where you can loop through the operational layers in the map. Sorry, one second. So you can loop through all the operational layers in the map. You can add or remove layers in this collection using the add and remove methods available on the collection. So one potential gotcha when working with collections is that the properties with the type of collection can't be watched. So if we want to know when the map layer's property changes, so when a layer is added or when a layer is removed, we need to register an event handler, the change event handler, to be notified.
So I want to talk a little bit about accessors in the ArcGIS API for JavaScript. So accessors are pretty key to the API. We use them pretty much everywhere. And they are essentially objects that you can read or set the properties on. You could set it so that it can be read-only properties. And what's really cool is you can define what the constructor arguments are going to be. And the most coolest part about accessors is that the property changes are watchable. So they're observable in your app, so you can watch for these particular changes and then do something. So essentially, they look just like regular properties, right? I can set the opacity to a layer. I can set the title of my layer, or I can use the set method. And I can set multiple properties at the same time, which is really neat. I can also go ahead and get nested properties. The real value here is the fact that if a map or base map is null, it's okay. It'll just, it won't error out when I try to get those nested properties, which is really kind of neat. And I can also set a nested property. So you see here I do view.set. Then I can go ahead and set a nested property, and it'll go ahead and create that for me. Property watching. So this is pretty much the key thing that you're going to use as a developer when you're working with the API, is that you're going to want to watch for property changes. This kind of replaces watching for, not watching, but listening for events that happen in the API. So essentially, in this case here, I can watch for the scale property of my view to change. And what you're going to get back when you do this is you're going to get back the new value. You'll get the reference to the old values. So you can, if they're numeric, you can do some sort of calculation of what the difference is there. The property that you're watching, in this case, is going to be scale. And then the target that you're watching, which in this particular case is going to be the map view, was the target, right? You could watch for nested property changes. So maybe I'm only interested if the title of my base map were to change. You can watch for that. And you can watch for multiple properties to change, which is also interesting. What you would want to do in that case here is you'd want to, in your handler, watch when you forget like ready or stationary changes, then you can check to see what the property was that changed and then do something based on that property. Maybe the function handler for this is going to be very similar across multiple properties in your app. So it saves you from having to write multiple functions that pretty much do the same thing. Autocasting. So this is really neat. So here's how you can do autocasting with a single constructor. You just pretty much provide an object that's going to look like the class that you want to create, and we'll go ahead and do the autocasting for you. So here what we're doing is that we're defining an object for a simple marker. We just tell it what type we want, the style, color. So the color is really neat because you can say color, just say red, or provide a hex value, an RGB value, or RGBA value, and we'll convert those into colors as you would expect in the API. And the same goes down here for the outline, right? You can see those two are different ways I'm setting the color, but we're going to go ahead and autocast those as well. So autocast properties also have other autocast properties in them as well, which is kind of neat. All right, so promises. Promises are pretty key in the API. A lot of stuff happens with promises. Here's a small chart from MDN showing kind of how promises work, right? So you have a promise. It could be either fulfilled or rejected. Once it's fulfilled, you call .then, and you can have a handler for that on fulfillment, basically as a success, or you can reject it, and you can have a rejection handler or .catch to catch that rejection as well. Then you can have some sort of async functions that happen here as well, and you can return those async functions to get a new promise, and then so on and so on. So this is what is called promise chaining, which is really neat. And we use that throughout the API. You see here that all asynchronous methods in the API return a promise. There's, I don't want to say there's no more events, but there are only events where they're needed, right? Which is going to be things like click handlers or other things like that, interactivity type stuff, which we'll actually cover in a little bit. But the basic patterns look like this. So I'm going to go ahead and query features on a layer. I pass in my query. That returns a promise that I can then go ahead and handle that result. And if something were to go wrong, I can go ahead and use .catch to handle the error in that promise. A couple notes. There is no more Dojo promise in the 4X version of the API. Everything's fully native promise. So if you were previously doing something like creating Dojo promises or Dojo deferreds and doing deferred.cancel or promise.cancel, that is no longer available. You want to use the abort signal if you need to cancel a promise, and I'll talk about that in a little bit. So along with promises, we also support async wait. So if you're not familiar with it, async wait is the modern JavaScript way of working with promises. You basically would need to define an async function, and now inside an async function, you can await for promises to happen. That's using the await keyword. So in my async function here, my results is going to be equal to the await of query features on the layer. So it's going to go ahead and be a blocking, that's important to know as well. This is now blocking inside your functions, so the next line of code will not run until this is complete. So it looks synchronous, but it's not, it's asynchronous. So we're going to wait for this query features to happen. Once I get those results, I can then go ahead and start doing something with those results, right? And then I can return those results as well. So I can then call this do query function somewhere else, and it'll be using async await. So what are the benefits for the promises, right? Basically, they let us lazy load certain resources. So when, and also, you know, when things are done, right? So if I create a map and I add that map to a view, by listening for view.when, at that point, the map should be loaded, layers should be loaded, the view should be ready to start drawing, right? Now, not everything on the map will be drawn, but now it's set and it's ready for things to get drawn. And that means that the DOM would be hydrated with the canvas, or actually the whatever elements it needs to create the map, and you can start doing some things with your page. If we look at some promise chaining, you could do something like view.when. In here, you could return view when layer view, which is going to return an async method, and we're going to pass it a layer. And then once we get the layer view, again, instead of another promise, we can use the watch utils to watch for when the layer view property updating is false, and we only care about when it happens once. So once this promise is resolved, we're going to return that. We get the result for that updating, and now we can go ahead and grab the layer view from the result target, and then query features on the layer view to get all the features that have been downloaded to be displayed on the map. And once we get those features, then do something. And then if something were to go wrong anywhere in this promise chain, we can catch the error down here. So it's important to note that if this promise failed up here, these chain methods will not run. It'll go down directly to the error handler down here. Async await. So here's how you do the same functionality using async await. So I'm going to create an async method. I'm going to await for view.when, and then I'm going to go ahead and get my layer view by doing an await on when layer view with the layer that I'm passing to it. And then go ahead and I can grab the layer view from the watch utils. And I don't necessarily need to do this, but I did want to just show how this could work if you wanted to. Basically, you're going to get the results back from this when false once, and there's a property called target on those results, but I want to rename that target as layer view over here, which is something that you could do. You could rename properties when you're calling them like this. Then I want to go ahead and get the features from the query features. And once I'm done with that, I can run this function, do something with features, right? And when you are running these, if you want to catch any errors that might happen anywhere in this await sequence here, you want to wrap them in a try catch. So I'm going to try to run the init function, and if something happens, I'll catch the error and then pass that error to whatever error handler that I'm using. And let's see what a demo of something like that looks like. So here I have a map that I'm going to load, and when the layer view is done updating, I'm just going to console.log done updating in here. Increase that font just a little bit for you. Okay, so I have this function watch layer views. I'm going to get layer view 1 and layer view 2 from two methods where I'm calling when layer view with two different layers. So I'm going to wrap those in promise.all, which is going to return a promise that's going to be an array of results of both of these layer views. That's how I get layer view 1 and layer view 2. So I'll just destructure that array. Then I'm going to await another promise.all because I want to wait for when both of those layer views are done updating. And when they are both done updating, I'm going to log out done updating in my console, which you can see down here. All right, so that's pretty cool. Abort signal. So I mentioned abort signal earlier if you need to cancel something happening in your promise chain, right? So the way this works is that you're going to create an abort controller, and that abort controller is going to have a signal on it. And you're going to want to pass this signal around wherever you're going to need it. In my case here, I'm going to go ahead and pass this request madness function. It's going to get a list of URLs, and I'm going to pass my signal that I got from my abort controller, and then I am immediately going to abort my controller, right? Or you can do this somewhere in your code. Maybe someone clicks a button to start requesting a bunch of data, but then they decide that they want to request something else instead, so you can cancel that previous request and do the new one. So the way this works is that I'm going to go ahead and start doing these requests for my URLs, and the Esri request inside the JavaScript API takes a signal as part of its options, and then somewhere inside of my code here, as I start going to wait for all the promises to resolve, and I'm using a promise utils, a way to do it. This is kind of like promise.all, but the cool part is that each always will return all the promises, even if one of them is rejected, whereas with promise.all, if one promise is rejected, they all get rejected. So use each always, and you can wait for them all to resolve. It'll take care of that for you. Then if there's if something goes wrong with the abort signal at this point, and it's been aborted, I can go ahead and return an abort error inside of my function here, right? So I can check for that abort signal to see if something happened. If not, I'll just go ahead and return the results. So you can see how that might work inside your code if you want to start using the abort signal in the JavaScript API. And that works on Esri requests. It works for the query features functions of the layers and the layer views, and a bunch of other query tasks. All right, so some patterns, right? We talked a little bit about interactivity, and this is where events come into play. So the view has a lot of events that you can listen to. There's a whole list of events listed in the API that range from click, double click to pointer events and things like drag, right? So if you want to work with like a view on drag, you can go ahead and stop propagation on that event, and that way it won't bubble up, right? But this is kind of one of the cases where you might want to do something like that. Interactivity of the view event, so maybe I want to do a view on click. I can get those XY coordinates that are going to be the screen points. These are not map points. And I do a hit test on the view for those screen points to find out if there's any features there. And then I get those response back and do something with the graphics, right? So I get my graphic back from the response. It's important to note here that this response.results is going to be for every layer. So you're going to get the topmost graphic from each layer on the map right now. Let's look at a quick sample for that. All right, so here's a sample from the API where I'm going to go ahead and listen for some click events. And as I mouse over these with the pointer, I'm going to go ahead and do a hit test, and I'm going to pull some information off of that graphic based on the hit test, right? Which is pretty cool. You can see here I'm doing it on pointer move and pointer down, and I have a handler that's just going to go ahead and handle that for me. Awesome. Goto with views. So goto is a great way to do some interaction in your apps. You basically can pass it just about anything. You pass it geometry, pass it a graphic, you can give it directly a location, and it's going to go ahead and navigate the view for you. Let's go to a quick API sample here. What's neat is that with goto, you can also provide your own, you can define the easing function that you want to use for the goto method, right? So we have a default easing function. There's a linear. There it goes, there it goes. It's very slowly. That's right, that's what it's called, linear slow. You have all these other easing functions, but you can also define your own easing function, right? So maybe I have a bounce to Berlin easing function. So I'll use that one, and then boom, boom, and boom. There we go. Look at that. I'm sure your users are going to love that, right? So again, you can define those easing functions. Something like in here, so I have a custom easing function in here. If you want to do that, you're more than welcome to. Loadables. So loadables are great in the API. We use them a lot. And basically, it's a great way to lazy load certain resources in the API. So for example, when you first create a web map, we are not going to load all the layers for the web map until we need to, right? So that web map's just going to kind of sit there, nothing happening until you add it to the view. And once you add it to the view, it's the view's job to go ahead and load the web map and then load all the layers that are part of that web map. Right, so if you look at this, the way this kind of works for web maps and web scenes, first we need to load the portal item. That portal item is going to reference other items, so then we have to load the layer module, and then we also load those layers items, and so on. So we schedule all these resources that need to be loaded in the API. That's why we have this loadable pattern. So what you could do is you don't even have to use a map view if you want to pull some data from a web map. You can create that web map, you can load it yourself, and once you've loaded it, you can grab a layer and then load that layer yourself, query the features for that layer, and then maybe display those layers in a table or some other kind of reporting form inside your application without ever having to display the map, which is really cool. Zoom or scale. So let me talk about this one for a second. There is a difference between zoom or scale. Now, if you look at this animated GIF here, basically what's happening is that I've got one map with the same zoom level, but basically one is vector tiles and one is raster tiles. And the reason for that has to do with the tiling difference between those two types of services. So it's important to note that zoom or scale are not the same thing. Not all levels of details are created equal. And that's essentially all that zoom is. Zoom is just the level of detail that you want to zoom your map to. But zoom is not scale, right? So if you define a scale in your map, scale is portable. So if I open that map in online or open it in Pro, that scale is going to be consistent everywhere, regardless of the base map that I use. So let's look at this little sample I've got going here. So right now I've got the base map, right? And I'm using zoom 12. But if I go ahead and, oops, do that and run it, and I turn on the vector-based map, you'll see right away it's a different level than what the raster-based maps were. But if I set the scale and not the zoom and let it run, okay, so we have a scale here for the vector-based maps. And if I turn on the raster-based maps, they are zoomed in to the correct location. Scale is portable. It has meaning. Zoom does not. So keep that in mind when you're building your apps. I know it's convenient, but you probably should be using scale better. All right, so sublayer to feature layer. If you're working with map image layer, the layers that are part of the map image layer are defined as sublayers, which are really cool. So you can take those sublayers and you can create feature layers from them. And once you get those feature layers, you can do other really cool things. So here's an example of taking the sublayer from a map image layer and then using the smart mapping functionality to go ahead and do something with them, right? So I get my feature layer. I am going to go ahead and use that feature layer as a source for some parameters to smart mapping and then run it. And then I'm going to apply that to my map here, which is just going to be some very basic outlines of my map. Nothing too crazy. All right, so layer create query. So a lot of times when you are creating, when you pull a layer into your applications, it's already going to have some filtering on it. It's things like layer definitions that are defined on it. When you do your queries, you want to honor those layer definitions. So what you can use is layer create query, and that query will automatically have those layer definitions on it. So if you query for features, anything that is excluded by layer definitions or included will be honored in the query, right? And if you don't want those, if you want to just go ahead and ignore whatever the layer is defined for its filters, you can just create a new query, and then none of those predefined filters will be applied. Just run this sample real quick for you. So I can basically get my layer in here, and then I'm going to create my query for the wells layer. Query earthquakes, right? So I'm honoring the layer definition that's been defined by my earthquakes, and I'm creating some buffers for them. Maybe I want to convert to producing well, and so on, right? So now I'm doing a bit more with them as I get the data. You can see how useful that is just to create the query from there. It saves me from having to create the query myself and maybe define any definitions or anything like that I don't really need. So the map image layer, again, if you want to modify the sublayers, a good rule of thumb is to do it after you load the layer. If you define the sublayers up front, then you pretty much override any defaults that might be defined on those sublayers. So you may not want to do that. It just kind of depends on if you know the data or not. This goes for applying maybe custom pop-up templates or something to the map image layer or anything else you might want, to the sublayers of the map image layer or anything else you might want to do. So in this case here, I'm going to go and load my layer, and I'm going to go and apply a pop-up to my layer, and then I'm going to go and add the layer to my map. So this layer didn't have a pop-up beforehand, but now that I've gone ahead and defined a pop-up template, it will, which is kind of cool. Layer views. So the layer views are in charge of rendering the layer. When is a layer view done, right? So essentially the layer view is done once it's loaded the layer and it's downloaded all the features and then rendered those features on the map, right? And that's, once it has the features and maybe you want to do some sort of client-side interactivity with it, then you can start working with it once it's been done, right? So here's an example of like when things are done. And we kind of saw this in an earlier example working with layer views. But essentially what you want to do is you want to wait for this updating property to be false. And when that updating property is false, that's when the layer is done loading. In this case here, once it's done, I would log out layer view has updated, layer view done updating, right? And then once I've watched for it the first time, if I need to know when the layer views are updated every time during running my application, I can just watch for that updating property to be false. Every time it's false, that means that the features have been downloaded and been drawn to the map. And with that, I'd like to thank you very much for coming to our session. Thank you.